Hello, everyone, and welcome to AI Explorer Journeys, our podcast where we navigate the world of artificial intelligence. I'm your host, Sarah, and joining me today is my co host, Kevin. Hi, Kevin.
Hi, Sarah. Hi, everyone.
You know that feeling when you're trying to copy some data from a website, maybe a stock price or a financial report, and you find out you can't? The text is locked inside an image, or the site just seems designed to stop you at every turn. It feels like the data is right there, but you can't touch it.
Right. It's a deliberate digital wall. And for anyone who relies on that, data analysts, investors, even just curious individuals, it's incredibly frustrating. It's a huge blind spot. But what's fascinating is that there's now a way to essentially give your computer a pair of eyes to read that unreadable information, completely changing the game.
A pair of eyes for the computer. I like that. So today, we're diving into this fascinating area: how image recognition is revolutionizing financial data scraping. Traditionally, web scrapers just fetch the underlying code of a website, the HTML, and extract information. But it seems like that's just not cutting it anymore.
That's exactly the problem. When a critical stock price or a key figure in a financial statement is embedded in an image, a regular scraper just sees an IMG tag. It has no idea what number is in that picture. This creates a massive blind spot. But with image recognition, specifically something called optical character recognition, or OCR, we can essentially read the text from a screenshot of the page, just like our eyes would. It turns those invisible data points into actual, usable information.
You've mentioned before that this is a cat and mouse game. Can you elaborate on that? How have these anti-scraping techniques evolved beyond just, say, blocking an IP address? And why is putting data in an image such a game changer for websites trying to protect their information?
Well, it's an arms race. In the early days, a website might block an IP that was making too many requests too quickly. Simple. But scrapers got smarter, using rotating proxies to appear as different users. So, websites evolved. They started using heavy JavaScript to load content dynamically, meaning a simple scraper that just reads the initial HTML would get nothing. Then came CAPTCHAs, the I'm not a robot boxes we all know and love. Rendering data as an image is the next level. It completely defeats any tool that only reads text. To a traditional bot, the most important number on the page might as well not exist. It's a brilliant, if annoying, defense.
I see. But doesn't this visual approach just move the problem? If a website really wants to prevent scraping, couldn't they just make the images harder to read, use weird fonts, add distortions, or constantly change the page layout to confuse the OCR software? What are the vulnerabilities of relying on visual data extraction?
That's a great point. And yes, they absolutely can. OCR isn't magic. It has its own challenges. If the image is low resolution, or the text is tiny, or it's written in some super stylized font that looks more like art than letters, the accuracy can drop. However, this is where the mouse gets smarter again. We can use image pre-processing, like increasing the contrast, scaling the image up, or removing digital noise to clean up the image before the OCR even sees it. And for really tough cases, you can train more advanced AI models on specific layouts or fonts. So while it's not a perfect solution, it's a huge leap forward.
So, it's clear that image recognition isn't just a fancy trick. It's becoming a strategic necessity for accessing financial data that websites are actively trying to guard. This brings us to the practical side of things. How exactly do we implement this visual scraping?
Absolutely. The core idea is surprisingly simple. Browser, screenshot, OCR, get text. We use a tool like Selenium or Playwright to run what's called a headless browser. Think of it as a web browser like Chrome, but one that runs invisibly in the background without any graphics. This allows our script to navigate to the financial site, wait for all the dynamic content and images to load, just like a real person would.
Okay, so the website server just sees what looks like a normal visit from a regular user.
Precisely. It's stealthy. Once the page is loaded, we tell the script to capture a screenshot, but not of the whole page, just the specific little box where the stock price or the revenue number is displayed. Then, the magic happens. We feed that small image into an OCR engine. The engine analyzes the pixels, recognizes the shapes as characters, and spits out the text. We've tested this, grabbing a stock price from a page that normally blocks scrapers, and it worked seamlessly in seconds. The website never knew it was a bot.
That's a brilliant explanation. To make it even clearer for our listeners, could you use an analogy? How do the headless browser and the OCR work together? Maybe like a special kind of digital camera and a very smart interpreter?
That's a perfect way to put it. The headless browser is like a silent, invisible photographer you send into a library that doesn't allow notebooks. This photographer can't write anything down, but they can navigate to the exact book and page you need, the one with the critical information. Then, they take a crystal clear photo of the specific paragraph you're interested in. They bring that photo back to you, and you hand it to a hyper-intelligent interpreter, the OCR engine, who can read any language, or in this case, any text from an image, and tells you exactly what it says. The photographer gets you the visual, and the interpreter turns it into information.
Got it. That makes a lot of sense. But you touched on OCR accuracy earlier. What are the common pitfalls someone attempting this would run into? If their results aren't perfect, what are the first troubleshooting steps they should take?
The most common issues are definitely image quality and fonts. Sometimes the text is just too small, or it's a light gray on a white background, which is tough for a machine to read. The first step is always to look at the screenshot your script is taking. Is it clear? Is it blurry? If it's not great, the first thing to try is image pre-processing. Simple techniques like converting the image to grayscale and increasing the contrast can work wonders. It's like adjusting the settings on a photo to make the text pop before you try to read it. If that fails, you might need to look into a more powerful OCR tool or even train a custom model, but for most standard numeric data, a little cleanup is all you need.
It sounds like a robust system, despite the need for some refinement. Now that we understand how to build this sophisticated scraper, let's explore the most exciting part. What kind of high-value financial data does this method unlock that we simply couldn't access before?
You're right, Sarah. This is where it gets really powerful. It's a goldmine of public financial information that's been hard to collect at scale. For example, think about trading websites or apps. Many of them display live quotes, charts, and technical indicators like the RSI or moving averages, but they don't offer a simple API to download that data in real time. With this method, you can capture it.
And it's not just real-time data, right? I imagine this is huge for historical documents too.
Exactly. Think about annual reports or regulatory filings from years ago. A lot of companies or archives just have them available as scanned PDFs. To a traditional scraper, that's a dead end. But to an OCR-powered scraper, it's a treasure trove. You can systematically go through thousands of these documents and extract revenue figures, net income, cash flow, all from what are essentially just pictures of pages. You can build a massive, structured historical database for hundreds of companies from completely unstructured documents.
You mentioned extracting technical indicators from charts. That sounds more complex than just reading a number. How would a visual scraper interpret something like a moving average from a chart image, and what kind of analytical advantage does that offer?
It's a bit more advanced, but totally doable. Instead of just reading text, you're doing some basic image analysis. For example, you could identify the colored line representing the moving average on the chart, trace its path across the pixels, and convert its Y position at different points back into a price value relative to the chart's axis. The advantage is huge. You're not just getting the raw price data, you're extracting a layer of pre-processed analysis, the indicator itself. This allows you to test strategies or build models based on signals that other people can only see, but you can actually compute with.
If we consider this from the perspective of a small independent researcher or a startup, what's the most impactful category of data you think this method makes accessible to them? How does this level the playing field against larger institutions that have expensive, dedicated data feeds?
I think the biggest impact is on those unstructured documents, especially regulatory filings and old financial reports. Large institutions pay fortunes for clean, historical data feeds. This method allows an individual with some coding skills to build their own. Imagine being able to pull 20 years of financial statements for every company in a niche industry just from public PDF filings on a government website. That kind of deep historical analysis was previously out of reach for most people. It democratizes access to the raw materials of financial insight.
It's clear this technique can transform how we gather and analyze financial data, turning previously hidden information into powerful insights. This naturally leads us to a critical question. How can these newly accessible insights be used, particularly in high-stakes areas like detecting financial fraud?
Absolutely. This is one of the most compelling applications. We've all heard of the massive scandals like LeTV, Luckin Coffee, and Kang Mei Pharmaceutical. These cases are textbook examples of how data anomalies, when you can see them, can reveal malfeasance. The truth is often hidden in plain sight, just scattered across different documents and reports over time.
So, how would this kind of data analysis have helped spot a fraud like, say, Luckin Coffee?
With Luckin, they fabricated over 2 billion yuan in sales. An automated system scraping public data could have cross-referenced their claimed revenue with other data points. You could estimate a realistic sales capacity per store based on location, size, and even publicly available foot traffic data. The numbers wouldn't add up. Similarly, with Kang Mei Pharmaceutical, they claim to have 88 billion yuan in cash. A system that aggregates their financial reports over time would flag an astronomical cash balance that isn't generating proportional interest income and doesn't align with their actual business growth. These red flags become glaringly obvious when you stitch all the public data together.
For a listener who finds this fascinating and wants to build their own system to monitor for anomalies, what's the most critical step in your roadmap? What's the key to making it reliable?
The most critical step, after you've mastered the scraping itself, is the data storage and historical tracking. It's not enough to just grab today's numbers. You need to save them in a structured way, in a database, or even just a series of spreadsheets. The power comes from building a time series dataset. Fraud isn't usually a single bad number. It's a pattern of numbers that don't make sense over time. Having that historical context is what allows you to spot an anomaly, like a debt ratio suddenly jumping or profit margins diverging wildly from industry peers.
This is incredibly powerful. But you've also stressed the ethical and legal boundaries. Given that this method is like a skeleton key that can bypass technical barriers, what's the most common temptation or misuse you foresee? And how can individuals proactively guard against crossing that line?
The biggest temptation is to get greedy. Just because you can scrape something doesn't mean you should. The most common line to cross would be trying to access data that's truly private information behind a login, personal user data, or content behind a paywall you haven't paid for. The key is to have a clear ethical compass. Stick to publicly available information. Read the website's terms of service. Don't hammer their servers with thousands of requests a minute. Be respectful of their resources. The goal is to use this power for research and insight, not to break things or steal information.
It's clear that while the technical capability is impressive, the responsible application of this power is paramount. This has been a fantastic deep dive, showing us not just the how and what, but also the significant why behind using image recognition for financial data.
So really, when you boil it all down, the first thing is that this is a strategic adaptation. The old ways of getting data are hitting a wall, so we're forced to evolve from just parsing code to actually teaching our machines to see.
Right. And that evolution is incredibly empowering. It democratizes access to this goldmine of public data, from real-time charts to old, scanned reports. It means an individual can now build their own powerful analytical tools that were once the exclusive domain of big firms, whether for their own research or even to spot those red flags of fraud.
But that power comes with a huge responsibility. That's the final, crucial point. We have to maintain ethical vigilance. Just because you can technically bypass a website's defenses doesn't give you a free pass. You still have to operate within the law, respect terms of service, and use this capability for legitimate beneficial purposes.
The ability to see and extract data where traditional methods are blind fundamentally alters the landscape of information gathering. Yet, as we gain new eyes, the true challenge shifts from technical feasibility to ethical discernment. How do we ensure that this enhanced vision serves to illuminate truth and foster innovation, rather than merely opening doors to forbidden chambers? The power of the skeleton key lies not in its ability to unlock, but in the wisdom of choosing which doors to open and for what purpose. All right, that's it for today's episode. Thanks for tuning in, everyone, and thank you, Kevin, for the great discussion. Before we wrap up, let me remind everyone today's discussion reflects personal views only, not investment advice. Please consult professionals before making financial decisions.
That's right. Thanks for tuning in to the AI Explorer podcast. If you enjoyed this deep dive, don't forget to subscribe to our YouTube channel. That's all for today. See you next time.